Good morning, students. Today we will study about the advantages of negative voltage feedback. The following are the advantages of negative voltage feedback in amplifiers. Number one is gain stability. The resultant gain of the amplifier can be made independent of transistor parameters or the supply voltage variations. And the voltage gain with feedback is given by AVF is equals to AV divided by 1 plus AV into MV. And for negative voltage feedback in an amplifier to be effective, the designer deliberately makes the product AV into MV much greater than unity. So the expression becomes AVF is equal to AV divided by AV into MV plus 1, and we can neglect the 1 in comparison to the AV into MV. So we get AVF is equals to 1 upon MV. And it is clear from this expression that gain now depends only upon feedback fraction MV. That is on the characteristics of the feedback circuit. And as feedback circuit is usually a voltage divider, feedback circuit is usually a voltage divider, that means a resistive network. So it is unaffected by changes in temperature, variations in temperature parameters and frequency, and hence gain of the amplifier is extremely stable. So gain will be stable. Now next is reduces non-linear distortion. A large signal stage has a non-linear distortion because its voltage gain changes at various points in the cycle. The negative voltage feedback reduces the non-linear distortion in large signal amplifiers, and we can prove it mathematically. The formula for the distortion in amplifier with the negative feedback, dVf is equals to d divided by 1 plus AV into MV, and here d is distortion in amplifier without feedback and dVf is distortion in amplifier with negative feedback. So it is clear from this formula that on applying the negative feedback to an amplifier, distortion is reduced by a factor 1 plus AV into MV. Distortion will be reduced in amplifier by a factor 1 plus AV into MV. Now third is improves frequency response. As feedback is usually obtained through a resistive network, therefore voltage gain of the amplifier is independent of the signal frequency. It does not depend upon signal frequency. As feedback is usually obtained through a resistive network, therefore voltage gain of the amplifier is independent of the signal frequency. The result is that voltage gain of the amplifier will be substantially constant over a wide range of signal frequency. The result is that voltage gain of the amplifier will be substantially constant over a wide range of signal frequencies. So negative voltage feedback improves the frequency response of the amplifier. It is due to the negative voltage feedback, the frequency response of the amplifier will be improved. For this, increase circuit stability. The output of the ordinary amplifier is easily changed due to the variations in ambient temperature, frequency and signal amplitude. The output of the ordinary amplifier is easily changed due to variations in ambient temperature, frequency and signal amplitude. This changes the gain of the amplifier, resulting in distortion, However, by applying the negative voltage feedback, voltage gain of the amplifier is stabilized or accurately fixed in value. So it will increase the circuit stability. The negative voltage feedback increase circuit stability. Now fifth is increase input impedance and decrease output impedance. Increase input impedance and decrease output impedance. The negative voltage feedback increases the input impedance and decrease the output impedance. Such a change is profitable in practice as the amplifier can then serve the purpose of impedance matching. The amplifier can be used for the purpose of impedance matching.